reciprocal and ratio IDs. Now the one thing that's a little bit different about those, when we talk about those, is you can kind of change those a little bit. There's no way for us to write every single ratio and every single reciprocal ID, because we could, like let's take this one. This could be tangent squared theta equals 1 over cotangent squared theta. That's another way to write a reciprocal ID. They could both be squared. If we took this one, we could say cosecant cubed theta equals 1 over sine cubed theta. So the way that we write, whenever a trig word is cubed or squared, you attach the cube to the word, not to the variable. Yes, if one is cubed and one is not, then they're not the same. Okay, then we got to split it up to where we have 3 of them, and maybe some of them will cancel, but not all of them. Okay, so very good question. If this was not cubed and this was cubed, then those are no longer equal. Okay, we can do the same thing with the ratio. If I take this one, tangent squared theta can be changed to sine squared theta over cosine squared theta. But we can only do those with those IDs that have one thing. Okay, just like if I had a 2, I could square a 2. Okay, if I had 2 squared equal, or 2 equals 4, I could multiply both sides by 2. As long as I'm doing the same thing to both sides, then it's okay. But if I'm not doing the same thing to both sides, then it's not okay. Which takes us to the Pythagorean IDs. There are 2 things on one side being added. So we can't say a Pythagorean ID is anything other than this. If there are not 2 words being squared with a combination of a 1, then it is not a Pythagorean ID. We cannot just take the square root of both sides and say that's a Pythagorean ID. Sine x plus cosine x equals 1 is not a thing. Now we can move it around. Okay, so let's take this first one right here. If I took that first one and changed it around, I can do that. So I could take this and I want to bring the cosine squared to the other side. So I could say sine squared a equals 1 minus cosine squared a. That's something I can do. So on your notes, when it says, can I turn 2 terms into 1? If I end up with a sine squared, some variable, capital A, theta, x, capital F, whatever it is, if these 2 terms end up in my final answer, I can simplify that more into just 1. If I end up with a 1 minus cosine squared in my answer, I'm not done. I can simplify that to just sine squared a. I'm trying to get it down to 1 word if I can. I could also say cosine squared a equals 1 minus sine squared a. That's another way I can manipulate. I am not changing the value, I'm just moving things around. 2 plus 3 equals 5. I could say 2 equals 5 minus 3. I could say 2 minus 5 equals negative 3. I can move things around all over the place. Okay, that works. I could say 3 minus 5 equals negative 2. I'm just moving things from one side of the equal sign to the other. So when you get confused with the words, think back to numbers. Numbers you were good with, and then you got to algebra and they added these x's and y's, and then that was confusing. Now we're adding words, but it's the same concept, just adding and subtracting. Let's see, I could say sine squared a, I could bring the 1 over and bring the cosine over equals negative cosine squared a. I could leave the cosine squared on the left, bring the 1 over, and bring the sine squared a over, and it becomes negative. I could move everything to the other side. I could bring the 1 to the left, and then I end up with negative sine squared a minus cosine squared a. So notice if the sine and the cosine are on the same side. Yep, still Pythagorean ID. Doesn't matter how I move it around. All of these are Pythagorean identities. So right there's 5 different ways I could write that one. So that goes for all 3 of them. There's at least 5 different ways. I can't really think off the top of my head if there's another one. Negative. I brought the cosine to both sides. I brought the sine to both sides. I think that's about it. So that one identity, 1, 2, 3, 4, 5, 6. There's 6 different ways you can write it, but all it is adding and subtracting. Don't think you have to memorize 18 different identities. You memorize sine squared a plus cosine squared equals 1, and then if you have any combination of a sine squared, a cosine squared, and or a 1, move it around and see what it is until it equals. Like if I have this right here, okay, well I look at this. If I bring this over, I get that. Now I can change my sine squared a into 1 minus cosine squared a, or whatever it is. Okay? So manipulating something doesn't change the identity. But taking the square root, dividing by 2, whatever, we can't do that. We can only move left to right. We haven't changed what it equals. Same thing over here with the numbers. I haven't changed what anything equals. 2 plus 3 equals 5. 2 equals 5 minus 3. All of these are still true. They're still the same. They all mean the exact same thing. One thing you have to think about, people always want to take the square root of that. So when you take the square root of that, think about if I took the square root of 9 plus 4. Those are both perfect squares. Is that the same as the square root of 9 plus the square root of 4? No. This is the square root of 13. This is 3 plus 2. I think we all know the square root of 13 does not equal 5. So notice I can't take the square root of 2 things that are being added and subtracted and separate them. That is not something I can do. So I can't just say I want to take the square root, square root, and square root. That doesn't work. Sine A plus cosine A equals 1 is not a thing. Only Pythagorean IDs have to be squared. Okay, they have to be squared. So tangent squared plus 1 equals secant squared. If you have a tangent squared and a secant squared together and a combination of 1, then know that there's something you could do right here. You could replace 2 terms, could turn into 1. We could bring that tangent squared. So we could say 1 equals secant squared theta minus tangent squared theta. That's another way you could do that. Same thing down here. We could say cotangent squared theta. I could bring that cosecant squared theta over to the left and that one over to the right. I could bring the 1 over. I could bring the cotangent over. All kind of different combinations you can do that. You can add and subtract it, but you can't change that it is a square. So those Pythagorean IDs are huge. You need to memorize them. No, it's the whole thing. I mean, if you want to write it like this, so this means sine of theta is squared, which means sine of theta times sine of theta. You have 2 of them. So you're not, when you multiply, it's the whole thing. This is the notation, because a lot of times you'll forget the parentheses, and if you drop the parentheses, that is not equal to sine theta squared. We will get to that, but right now, squaring the angle is not the same as squaring the whole thing. And how you can kind of think about that, going back to unit 1 and 2, if I had sine of, let's say, 30 degrees. We know what that is, right? We go to 30 degrees, we look at the y value, that is equal to 1/2. Now if I say sine of 30 degrees squared versus sine of 30 degrees squared, sine of 30 degrees is 1/2. 1/2 squared is 1/4. This is the sine of 900 degrees. Who knows what the sine of 900 degrees is? So you see the difference? Okay? Squaring the whole thing versus squaring the variable right here, in this case the angle. Okay, squaring the angle, much different. So a lot of times you're not going to see it written like this. You're going to see it written with the squared on the word, and that's very important that you know the difference between the two. If you want to put it on the outside, that's fine. You can see, you might see it written somewhere. Someone might write it that way for you. But it's the whole thing being squared, not just the angle. All right, and then the other one that we're going to talk about today are the even and odd identities. These are new for you. And this side right here is the unsimplified. Okay? So we are never going to change a sine x to a sine of negative x. This side is always going to be your simplified version. So if it's already in this form, if you already have a sine x, it's never going to be an even or odd identity. If you have a negative in the angle, okay, if the angle is negative, that's when you're going to simplify it before you do any kind of operation. And as far as which ones are even, which ones are odd, okay, so right here, my original whole function was positive. When I put in a negative, I got a negative. That makes this odd. So that goes for cosecant also, because it's the same. Cosine, if I put in a negative angle, it gives me, or I have a positive function. If I put in a negative, that gives me a positive function, so that's called an even function. And later on when we get into even and odd functions, we'll talk about why they are, where they're symmetrical about, stuff like that. If you're in Algebra 2 for AP, I think you might have talked about even and odd functions, but in regular algebra, I don't think you did. And then here, this function is positive. When I put in a negative x, it results in a negative, so that's the opposite. So that's odd. So the reason I'm going over these is because when we get to the proofs, we have to say why, our reasons. Why did we, like it's kind of like in geometry, you had all those like postulates and theorems and definitions, okay? What is the reason you changed? If we go from sine negative x to negative sine x, your reason is odd identity. That's what you would write over there. If you had this in your proof and you changed it to this, your reason would be even identity. So all these identities, this sheet right here, these are the things along with add, subtract, multiply, divide, common denominator, something else we could do, multiply by the conjugate, multiply by the reciprocal, divide or multiply by the reciprocal, those are the same things. So all of those things, those are the reasons. What did you do to get to your next step? So when we do the proofs, that's all it is. What did you do to get to your next step? And you write the reason over to the side. Okay? So those are the ones we're going to talk about today. Reciprocal ratio, Pythagorean and even odd, those are the new ones that you haven't seen before. These you're going to just keep using over and over again. All right, so these first examples are not necessarily simplifying. It's just getting used to using your identities and what you might have to do in order to simplify. There's more than one answer for some of these. So like cotangent x. One way we could write cotangent x using an identity would be 1 over tangent x. That's a true statement. That's using a reciprocal ID. Using the ratio ID, we could say cosine x over sine x. So that right there, two different ways. So depending on the problem, there's no way to say whenever you see cotangent, change it to 1 over tangent. Or whenever you see cotangent, change it to cosine over sine. It depends what it's attached to. We don't know which one to use. We just know we have two possibilities, and either one of those might be something that will help us get to a more simplified answer. All right, sine negative x. Really, there's only one thing to do there using our odd identity. So sine of negative x, the only way to use an identity to change that, negative sine x. Because it all depends if something is attached to that, like if something's being multiplied by cotangent x, it might be helpful to use this, or it might be helpful to use this. We don't know which one. And maybe you use one, and it didn't work, so then you erase, and then you pick the other one. Okay, so we don't know which ones are going to use until we look at the problem. All right, cosine squared y. We could use our ratio ID and make that 1 over secant squared y. Might be helpful. Or when in the problem there might be a sine squared involved. If there's a sine squared involved, then we use our Pythagorean ID. So our Pythagorean ID is sine squared. I'll use that variable, y. Doesn't matter what variable you use, but use the one that's here. Okay, just because we use theta doesn't mean it has to be theta. We use whichever one is in the problem. Plus cosine squared y equals 1. So if I want a different way to write cosine squared y, we could bring that over. So this is also equal to 1 minus sine squared y. So there's two different things I could rewrite, again, depending on what I need in the problem. I don't know what I need until I see the problem. And then tangent, there's at least 3 different ways we could write this. So we might need that Pythagorean ID. So let's look at our Pythagorean ID again. This second one right here, tangent squared. So I could get rid of that 1, bring it over to the other side. So one way to rewrite that would be secant squared x minus 1. But I might not want to make 2 terms. I have 1, depending on, again, what is in the problem. I might want to keep it all together, so I could say 1 over cotangent squared x, using the reciprocal ID. Or I could say sine squared x over cosine squared x, using the ratio ID. Now, some books and some people call that the quotient ID. We call it the ratio ID. So again, just be sure you use those words that are on your notes right there. That first page of notes, super important to have with you at all times right now. Okay, all of those IDs so that you can start memorizing them. All right, now this right here, obviously this is not going to be a unit about multiplying 3 times 1/3. But if we go back to just thinking about 3 and 1/3, 3 times 1/3 is 3 over 3, which is 1. We can just look at that and know that's 1. Those are called reciprocals. Anytime you multiply reciprocals, the result is 1. Same thing with letters. X times 1 over x is equal to x over x, which equals 1. Same thing goes for words. Okay? Words are a little bit more difficult because you have to know which ones are the reciprocals. So back to unit 1, 2 and 3, we talked about reciprocals. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. So when I multiply reciprocals, my result is 1. Okay, well why does that work for that one? Okay, because if I used my reciprocal ID times 1 over sine theta, that gives me sine theta over sine theta. Anything divided by itself is 1. That is not something that we ever make you show. We make you show a lot of stuff. You're going to have to write a lot of stuff. So if you're one of those people that don't like to write things down, okay, you just better get ready to write everything down. You cannot skip steps on any of this. Once you are doing a proof or a simplified problem and you skip a bunch of steps, it's wrong. There's nothing else. It's not like we're grading this off of that. On a proof, once you mess up, you're done. The rest of it is wrong because it's a proof. It has to go in order. If someone is looking at your proof who doesn't know anything they're doing, they have to be able to follow. And if you mess up, then you're done. So you have to show everything. Reciprocals is something we don't make you show. So that's one thing. If you learn it, you don't have to show me these steps. Sine and cosecant, you know their reciprocals, equals 1. We could make that sine squared. Cosecant squared, still 1. Because this is squared, 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 it's still 1. Now, if one of them's squared and one of them's not, that's different. But if they're both squared, they're both cubed, they're both to the 4th, 5th, 6th, 10th, whatever, then multiplying reciprocals equals 1. Important to know your reciprocals, that sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. Tangent and cotangent is the easy one. It's the cosecant and secant that get mixed up sometimes. Right? So this is just kind of an expanded version. If you printed your notes, it's a little bit more concise. So I said on your notes, that first example, it says, do you have a fraction? Okay? If you have a fraction, you can get rid of it. You want to try to have one term. Okay? So if you have more than one term, look and see, is one of them squared? Or are two words squared? Are those words go together with the Pythagorean ID? Do you have a word squared and a 1 or a negative 1? Look at your Pythagorean IDs. If it's just sine x plus 1, there's nothing you can do. Sine x plus 1 is sine x plus 1 always. But if it's sine squared x with a 1, then there might be some kind of manipulation you can do. And then right here, this plus 2 thing, this means if you have, let's say you have a squared word with a 2, you could do a squared word 1 plus 1, and now you have a squared with a 1, and there might be some simplifying you can do. But you're always thinking about factoring, getting a common denominator, GCF, all of those different things. Multiplying by the reciprocal, changing, using all of your identities. All right, so now let's do a few practice, and then you'll have your classwork to do. So sine cotangent. Never will we give you a problem and you're just done. Nothing you can do. No solution. Not even a possibility. It doesn't say solve anything. Okay, we're going to give you something. You can do something to it. So I could change sine, but when I look at cotangent, okay, sine and changing that to 1 over tangent, that doesn't help me because now I have sine over tangent. So now I've created a fraction and I don't want a fraction. But cotangent, I can rewrite with a sign involved. So if I say sine x and I change cotangent to cosine x over sine x, now there's things I can simplify. So I can simplify sine x over sine x right there, and I get cosine x. One word, no fraction, I'm done. If you get down to one word and there's not a fraction, you know you're done. So as far as reasons go, so what made me go from given to this first step? That was the ratio ID. And what helped me go from here to here? Sine divided by sine, that would be division. Sine divided by sine is 1, and so that's what got me to cosine, divide. Cancel, simplify, you'll never ever use the word simplify, never use the word cancel. Okay, don't use reduce. We're going to use, if we're doing that, I mean, we say we canceled those, but that's not a mathematical term. We divided them. So if we divided them, then we got our answer. And again, we're not going to ask you for reasons on the simplify, but if we start talking about them now, it just makes it easier later on. All right, cosecant over secant. Okay, well, there's no really ID as far as Pythagorean, so we got to think about our ratio and reciprocal. There's no ratio, so the only thing to do is reciprocal. So I'm going to change cosecant to 1 over sine x. I'm going to change secant to 1 over cosine x. I have made this a little bit more complex than what it started with, but you sometimes have to make it a little bit bigger to get smaller. So now I have a fraction and fractions. What I did right here is I used the reciprocal ID. Now, I can't divide fractions. Dividing fractions, easy as pie. Flip the second and multiply. So 1 over sine x times the reciprocal of the denominator, cosine x over 1. You can say the reason I was able to go from here to here is multiply by the reciprocal or divide. Dividing is multiplying by the reciprocal. And then that ends up being cosine x over sine x, which we could say I multiplied that. That could, one reason we use is called a rewrite, so I kind of just rewrote it. And then cosine over x, I have a fraction. No fractions. Yes? Exactly. Add, subtract, multiply, divide, LCD, multiply by the reciprocal, absolutely. Cosine over sine would be cotangent x. One word, no fraction. For sure, no fractions. The one word can't always happen. Sometimes you have, or one term can't always happen. Sometimes it can, sometimes it can't. All right, tangent cubed minus secant squared tangent theta. So we could change things, but before we start changing things, I'm going to look. I have two separate terms, and I have a cubed in there. And there's no like cubed anywhere else. So if I look, I have a tangent in the first term, and I have a tangent in the second term. So think about if I had x cubed plus y squared x. Do those two things have something in common? They have an x. Well, we can't cancel. We can factor out the x. Can't ever get rid of anything. So here, we could take out a tangent theta, because I know tangent squared and secant squared go together as far as our Pythagorean ID. When I look at my Pythagorean ID, if I can get a tangent squared and a secant squared, that'd be great because I can simplify that. So if I take out one of those, I'm left with 2. Tangent squared. I took that tangent out, so minus secant squared. Well, I didn't distribute. Factor. Yep. So this is factor. If I were to distribute the tangent in and multiply, distribute or multiply are the same. But if I'm undoing it, I factored it out. All right, so now does this look like anything on our Pythagorean IDs? Those words go together. Tangent squared theta plus 1 equals secant squared theta. So if I brought that secant squared over to the left, I'd have to bring the 1 over to the right. So tangent theta times negative 1, negative tangent theta. No fraction, one term, I'm done. Don't change that into sine theta over cosine theta, now you have a fraction. Now you're unsimplifying it. No fractions, and try to get one term. All right, when there is a negative in the parentheses, that is your even and odd identity. So the sine negative x and the cosine negative x, those are even odd. The tangent x, that's just normal. So we're going to talk about that when we get to it. So this right here, we're going to have 3 terms. I suggest using parentheses right here, because what happens if you use a dot and then you have a negative, all of a sudden a multiply problem turns into a subtracting problem. So sine negative x, we just look at our odd identity. Very good. Cosine negative x, even identity. And now tangent doesn't go with sine and cosine, but I can change tangent to sines and cosines. Make that sine x over cosine x. So we had odd identity, even identity, ratio, and it's all multiply, so now I can just cancel. Cancel, cancel. And now I have sine times sine, so that's negative sine squared x. Because I have a negative times a positive, so that's a negative. The squared goes with the word, not with the variable, because sine x is what's being squared, not just the x. If it was sine x times x, then the x is being squared. But it's sine x times sine x, so the whole thing is being squared. All right. And that is it. Again, just those